Let me show you how we can pass environment variables of the cube deployment into the dbt sandbox. This dbt project reads the secret from environment variable. Let's try to pull this project into the cube deployment. We see that dbt pull failed, and when we look at the error details, it says that the env variable is required but not provided, the dbt demo API key. So let's set this up. Let's go to data source settings, open the dbt project settings, scroll to environment variables section, and let's pick the variable from the list. We see that the required variable is not on the list. Let's add it into the environment variable. And let's get back to dbt project settings. Let's open the environment variables, pick the dbt demo API key, and save the dbt settings. Once the dbt settings are saved, let's repeat the pull again. So we see that now dbt pull was completed, and here are the 4 cubes generated from the dbt model. Now let's look how we can infer the real column types from dbt's generated catalog.json to improve the quality of our generated cubes. Let's look at the dim customers SQL in our dbt model repo and see that we have no data type declared anywhere. So cube had to guess from the name what is the data type for every column. And let's look what happened from these heuristics. We see that, for example, the customer unique ID, which should be the 32-char hash, was recognized as a number. We see that the column updated by was resolved as a time. And also the amount bucket was resolved by a number because cube found the word amount in this dimension. Let's now configure the pull options and turn on the infer column types. We go to data source settings, pull options, and let's turn on the infer column types from dbt catalog. So what this does, it runs the dbt docs generate, reads the real warehouse types. So we need the reachable warehouse with these build models. Let's also put the prefix for our newly generated models so they will not interfere. And let's put them into model cubes dbt after. Let's now save it. And let's rerun the pull again. So the pull is completed. Let's look at the result. So we see that now customer unique ID was recognized as a string, which is correct. Updated by field is the string, which is right, and also the order amount bucket again is the string. Also, which I did not previously mention, the total order amount bucket was recognized as the measure with the type sum, which was untrue, and the correct resolution was that the only default measure count was generated. And let's look how we infer the primary key and determine the primary keys from dbt metadata. Let's look at the model YAML file. For example, the dim subscriptions model. We see that the subscriptions SK column has the data test that says unique, not null. Let's go to data source settings, uncheck detect primary keys from unique and not null test. And let's run the pull again. But first, let's look at the primary keys. here it was determined correctly. Now let's pull it again. Once this pull session was completed, we now see that the subscriptions SK column is not primary key anymore, and instead the legacy order ID was determined as the primary key based on heuristics. So this means that it is preferred to use and utilize this option, which is enabled by default here. And also, let's look at the generating reverse joins, as the DBT can only declare the relationship in one direction, and cube join graph is directed, so the query can be done more efficiently. So let's save this, and again, let's run the pull. Once the pull is completed, we can examine the results. This is the previously generated dim customers cube model file, which has no joins here. And this is the newly generated cube model file after we toggled the auto generate reverse joins, which has 3 joins to related cubes.